Okay, so this presentation shouldn't take too long, but I want to go through this topic not only because, like I say, you can't really talk about Mars without talking about dust storms, but also it provides a good example for talking about two very important principles throughout science and technology and cybernetics and control theory in general. This idea of positive and negative feedback mechanisms. So we talking about dust storms, but one of the key things I want to do is to use that as a way to illuminate what's going on with these positive and negative feedback mechanisms. So first of all, let's see if I can kill the lights and be able to bring them back. Mars is subject to dust storms to a much greater degree than the Earth is. What is probably the most famous dust storm? Dust Bowl, right? Okay, so bad agricultural practices in the early 20th century led to, and a drought on top of that, led to much of Oklahoma turning into dust and blowing around the countryside. We had dust from Oklahoma and regions further southwest showing up in the Atlantic coast, New York City, and triggering the huge migration of people, especially poor agricultural people, out of Oklahoma to, say, California. And so, big societal dislocation. That's nothing compared to what's going on Mars. Mars has the ability to generate planet-circling dust storms. So here's one example. The year 2001, well, since 2001, there have been maybe this and two other, really planet-circling dust storms, as well as minor regional ones. So you can see that as of June, late June that year, there were some small dust storms that were beginning to pop up here in which hemisphere? Southern hemisphere, okay. So, not quite maybe over to Hellas Basin, but, south and east of Valles Marineris there in the middle. And this is an image from the Hubble telescope. So within about a month and a half, this is what Mars looked like. So what do you see? Dust. You don't see nothing else. Well, you can still see the polar caps a little bit. It took weeks and months for that dust storm to abate. So we have nothing like this on the Earth. So what is going on here? Even when we don't have the global dust storms, oftentimes there are much more localized or regional dust storms. You can see them going across the landscape, as these fronts of dust clouds that are, going from a higher pressure area to a lower pressure area, following with the winds. This obviously is not a photograph from a rover. It's an artist's conception, but from the ground, these would be fairly impressive. And there are things that we're going to have to deal with when we send humans there. Now, we haven't talked about this in detail, but the winds on Mars can get up to, say, 200 miles an hour. But why is that less of an issue? Why is having a 200 mile an hour wind on Mars not such a big thing compared to having a 200 mile an hour wind here on the Earth? Is a 200 mile an hour wind going to blow you over? I will say no, and I will ask you, why will you not be blown over by a 200-mile-an-hour Martian wind?
Denser atmosphere compared to Mars and Earth. Is that what?
Yeah, it's a less dense atmosphere. So again, the atmospheric density on Mars is less than 1% of the density of the atmosphere on the Earth. So yeah, the air masses are moving very quickly, but there's just not a lot of momentum there. Okay, so you can think 200-mile-an-hour winds, but don't think earthly 200-mile-an-hour winds. The main issue with dust for human exploration is dust plays havoc with all of our machinery. Okay? The dust that is in here is a range of particle sizes, but in particular you have these particles called fines, very, very tiny particle size, talcum powder kind of dust. And when that gets blowing around at 200 miles an hour, I don't care what kind of door seals you've got on the airlock of the habitat, what kind of grease fittings or whatever you've got on your rovers and other machinery, it's going to be a real nuisance to have to deal with this situation. Yes, although nothing like that storm front coming through. I'll show some images from the Opportunity rover. Not so much of dust clouds and stuff, but what impact it has on the availability of solar radiation. Here again is this is in 2012. It's a little bit more difficult to see, but this is a mosaic of images from the Mars Reconnaissance Orbiter, the Mars Color Imager. And so we've got all of these strips of images taken as the MRO is going along in its polar orbit. And it's more difficult to see, but you can see that there is, at this point, had developed a dust field, a dust storm that covered, I don't know, fifth or sixth of the planet. Curiosity rover was over here, and Opportunity rover was over here. So in this case, this particular storm didn't threaten Opportunity, and Curiosity rover would actually not be threatened too much by the dust storm. It kind of detected some of the atmospheric effects of changing pressure and so forth that were associated with this storm. But in this case, neither one of them were really directly impacted by this regional storm. Okay, so the questions would be, how do these dust storms develop? Why are they different than the kind of dust storms we find here on the Earth? And how do they go away? So, dust devils. How many of you have not seen dust devils? Have not or have? Have not. Okay. Really? Yeah. Should live out west a little bit more. Dust devils are like little small whirlwinds. If they were larger and in the Midwest and associated with thunderstorms, you'd call them what? Tornadoes. Okay. Essentially, well, I've laid out here what's going on. You get these dust devils or tornadoes happening on the Earth, and these dust devils happening on Mars. When you get this localized heating of the ground here, again, when the ground surface in an area gets heated up, what's going to happen to the air temperature in that area? Okay, the warm air is going to be heated. That warm air is going to rise, and essentially, with these dust devils, you have these rising columns of air. The atmosphere actually gets somewhat unstable. You've got less dense, warmer air underneath, and more dense air on the top, and so the tendency would be for that to turn over and have the less dense air rise up but it doesn't necessarily happen right away until some local instability causes a column of air to start rising in a particular place. And when that happens, that's going to lead to a lower pressure in the area where that air is rising up. Other air is going to rush in and continue that upward flow. And because Mars and the Earth are spinning around, these columns of air start spinning. And so you get this little column of air that's spinning around, going across the surface. And that rising air is going to pick up what off of the surface of Mars? Dust. It's not going to pick up rocks. It's going to pick up dust. So you're going to see the dust that's in the dust devil is basically what allows you to see that rising column of air. I've watched dust devils out west, California, Arizona, and so forth, and you'll see the dust devil going across the open fields because it's picking up dust. And then that column of air will go across a road or something that all of a sudden doesn't have any dust anymore. And it'll look like the dust devil disappears. But, the air is still there swirling around. It just doesn't have any dust in there for you to see it. Crosses the road, starts picking up dust again, and voila, it pops up. The rovers have picked up multiple images of dust devils, just as part of their panoramic camera activity. And so this would be from, given the terrain, this would be from Spirit when it was climbing up in the Columbia Hills. And, taking a picture off in the distance, you see this relatively large dust devil. These are also picked up from orbit. So here's an image. I'm guessing, I don't know what camera this could be from a number of different cameras. But the dust devil is right here. Light colored dust that the rising air mass has picked up from the surface of Mars. And the dust in the dust devil is thick enough that it casts a shadow out onto the landscape. And from a lot of Mars orbital images, you can see these tracks, these scribbles across the landscape. Not wind streaks, but basically areas where the dust devil has been meandering around, picking up dust. If it pulls up light-colored dust off of the landscape, it might leave a dark track. If the dust on the land surface is darker than the underlying rock, it could leave a light track. But you'll see these dust devil tracks in a lot of orbital images. So what does this have to do with dust storms? Well, actually, before we talk about this, here's a particularly impressive dust devil that was picked up clearly from orbit. This particular dust devil is almost a kilometer high in height, 30 meters in diameter, so a football field would be approximately 30 meters wide, I'm guessing. It's basically 100 meters long, so a third of a football field in length would be how broad this dust devil was. Okay, so how does this all work? We have essentially positive feedback mechanisms leading to the creation, the onset of a regional and then global dust storm. And then later on, negative feedback processes result in the dust storm abating. So positive feedback mechanisms basically are situations where some stimulus to the system results in a change that amplifies that initial stimulus, which results in more change, which results in more stimulus, which results in more change. Okay? So it's like what would be, well, I won't go into how flushing a toilet might be comparable to positive feedback mechanisms, but with this local heating in an area, we've already talked about how that can generate dust devils. So increasing temperature basically can result in increased number of dust devil activity. When you have more dust devils, that's going to lead to an increase in dust in the air. And when you have more dust in the lower atmosphere on Mars, that all of those dust grains are surfaces that can absorb solar radiation. So would you expect dustier air to be warmer or colder than clear air on Mars in general? Warmer, okay. So as the dust load in the atmosphere builds up, that is going to lead to more heating up of the atmosphere. And then that's going to lead to more dust devil activity, which is going to lead to more dust and opacity in the atmosphere, meaning more absorption of solar radiation, meaning more heating of the atmosphere, meaning more dust. So you have this cycle progressing around with increasing dust activity, generating basically this self-sustaining mechanism that leads to essentially local and regional dust storms developing. Now when that happens, these dust storms themselves become areas of low pressure at the surface. They're going to draw in winds from the surrounding area, which is going to feed in more dust. And so if this process continues long enough, you're essentially going to get the whole planet surrounded by a global dust storm. So remember when Mariner 9 arrived at Mars and went into orbit? What did it see?
Well, you tell me.
You tell me. Okay. It's been a few weeks. But remember when Mariner 9 went into orbit, it was our first orbiter Mars, and it didn't see anything initially, and because of a global dust storm. The Soviets were successful at also putting 2 spacecraft into orbit at the same launch window that we sent Mariner 9. But their spacecraft were programmed to arrive in orbit, carry out their tasks of taking measurements and so forth, and then basically shutting off or being terminating. And so the Soviets got nothing but pictures of dust in the atmosphere. NASA had the ability to basically put Mariner 9 in hibernation and then wait out the dust storm. And remember, what were the first features on the planet that Mariner 9 saw as the dust storm abated? What?
Craters.
No, not craters.
That Valles Marineris.
Not Valles Marineris. So it would take a while before the air would clear enough for the orbiter to see down to where Valles Marineris is. What features stick up highest in the air? No, the volcanoes. Which ones? Olympus Mons and those Tharsis Monte volcanoes, Pavonis Mons and Ascraeus Mons and Arsia Mons. Because they're so high, as the dust begins to settle, they were the first things that Mariner 9 saw. And it took a while for the dust to clear enough to see Valles Marineris and the outflow channels and valley networks and Hellas Basin and so forth. So positive feedback mechanisms generate these dust storms. Negative feedback mechanisms basically shut them off. If you think back to those images where we had a global dust storm, once this dust storm develops, what's going to happen to the amount of sunlight that can get to the ground surface? It will decrease. What's going to happen to local ground temperatures as that as there's less sunlight coming in. Cool off. So basically, that process, in this case, the more dust there is in the atmosphere, the more it cuts off sunlight to the ground surface. The more the ground surface cools off, the more that inhibits rising air masses, which eventually, shuts the whole system off. And what process is actually then going to remove the dust from the atmosphere? Gravity. So again, these are very fine particles, so it may take weeks or months for all that dust to settle out onto the surface of the planet for the atmosphere to clear up again. Colin.
Since the atmosphere is so thin on Mars, does the wind hold more or less dust than it would on air in the Earth?
It will take greater wind speed to move a comparable amount of dust or a comparable size particle on Mars compared to the Earth.
Okay.
I mean, the reason why we don't have global dust storms on the Earth, well, we've got oceans, we've got vegetation, we've got a lot of things that would interrupt this process of generating huge masses of dust that are rising up in the atmosphere. Okay. So, I think I have to kill the lights again for this one. Opportunity had only been on Mars for about 3.5 years when it was almost, quote, killed by the global dust storm that occurred in 2007. So the one I showed you earlier was a global dust storm in 2003. 2007 also saw a global dust storm. You can see in this figure over here, kind of a before, what the Mars looks like from orbit before the dust storm develops and afterwards. And opportunities right here in Meridiani Planum. And clearly it's experienced a lot more dust at the height of this global dust storm than before. Now, why is that an issue for the Opportunity rover?
Solar cells.
It's solar powered. Okay. The Spirit and Opportunity rovers were never thought that they would go beyond the first 90 days, 90 sols on Mars. They were thought that they wouldn't necessarily be able to survive the Martian winter. But by this time, Opportunity had survived 1 or 2 Martian winters. Every now and then wind comes along and blows the dust off the solar panels. But in this case, you can see here are panoramic camera images down in this part of the figure, just looking across the landscape. And let me move this over a bit. Okay, so you can see that as this dust storm develops, just looking across the landscape, just looking across the landscape gets more and more difficult over time. Okay? So this sucks for taking any pretty pictures, but again, the important point is that at the same time, the amount of solar radiation falling on Opportunity solar panels is also decreasing. This is a situation where, generally speaking, as part of their operations, each day Opportunity would point one of its cameras at the sun and take a picture. And the sun's brightness is not varying that much from day to day, so what will influence how bright the sun looks in these pictures? The dust, the opacity of the atmosphere. If the atmosphere gets more and more opaque, the sun will look dimmer and dimmer as Opportunity is taking the standard picture each day. And they use that to calculate a measure of how opaque the atmosphere is. It's called tau, or the opacity measure. It's kind of like the inverse of the transmission of the sunlight through the atmosphere. So the higher the tau level is, the more opaque the atmosphere is, the less sunlight is coming down. And as this storm was proceeding, power levels on Opportunity rover kept getting worse and worse and worse. Opportunity was less and less able to charge up its batteries during the day to keep it alive overnight. Mission planners progressively shut down instrument after instrument to reduce the requirement for power. And during the height of this storm, they actually put Opportunity into a deep hibernation mode where they weren't even having the rover phone home each day. And they basically said, wake up in a couple of weeks and try to contact us, and they had no idea if Opportunity would return their call after that 2-week period. But fortunately, it survived, made it through. The dust storm eventually abated, and power levels went back up. And of course, now it's been on Mars for over 11 Earth years, plugging away, doing science.
Doing science.
Doing a science. So, remember there was a global dust storm in 2001. There were some regional dust storms in 2003. 2007, we had another global dust storm. In 2012, we had a really large regional dust storm. Clearly these big events occur with, at certain parts of the Martian year. And the take-home message is that the really big global dust storms are most likely to happen during the southern hemisphere summer. Now, it doesn't mean that when it's summer in the northern hemisphere we can never get any dust storms, but it's really the southern hemisphere summer that that leads to the greatest amount of dust storm activity. And so this actually is going to lead into the quiz, so I'm going to stop yammering.